might be wondering, how fast would you end up falling the instant before you hit the ground if you were to fall from, say, like an airplane or something? Well, today we're going to figure out how to calculate that for ourselves. So to figure out the max speed that we're going to hit the ground with, we're going to have to calculate the terminal velocity. So the terminal velocity is the point where the air resistance equals the weight of the falling object, which means that it no longer accelerates downwards, but instead it's falling at constant or terminal velocity. And to figure this out, we're going to have to set up two equations. The downward force is going to be represented by the weight, which equals mass times gravity. The air resistance force, which is going to act upwards, equals the density of air times the drag force coefficient times the area the air is acting upon divided by 2 times the velocity of the object squared. So to derive this equation, again, we're going to set them equal to each other. So the weight force is going to equal the air resistance force. So then we set both sides equal to each other. So we have mass times gravity equals rho times the drag force coefficient times the area divided by 2 times the velocity squared. We can then multiply both sides by 2 and then divide both sides by the rho times the drag force coefficient times the area. Then we take the square root of both sides and we end up getting the final solved equation for velocity. Of course, everyone's favorite part of that, plugging in all these values into our derived equation. So for this example, we're going to use the average American man. So we can solve for the terminal velocity by plugging in that the average American man weighs about 88.8 kilograms. Gravity we will assume to be 9.8 meters per second squared. The density of air around sea level is 1.225 kilograms per cubic meter. The drag coefficient of a human body curled up in a ball is around 0.7. And the average body surface in this position is about 0.95 meters squared for a man. So if we plug all these values into the recently derived equation, we will end up getting a value of about 46.2 meters per second. So the actual value of a skydiver falling at terminal velocity is around 53 meters per second, according to Wikipedia. So that raises the question, why is there a slightly different number? Well, our calculation assumes two things. One, that the orientation of the falling person is balled up, which you probably wouldn't do for any significant period of time as a skydiver, and that you're already at sea level, which means you're already very close to the ground. And in most places in the United States or around the world, the ground is above sea level, so you would never reach sea level. If you want to test this concept out a little bit more for yourself, then feel free to rewind. I have some data for women, so you can calculate the average American woman's terminal velocity. Feel free to calculate this for yourself and compare it to the average man's terminal velocity. Maybe leave some comments below, some feedback. Any questions, comments, feel free. Thank you for watching.